All right, guys, so what we're starting today is Chapter 7. Now, Chapter 7 is going to be covering rational equations. So when we talk about rational equations, we're talking about equations that are fractions, because rational means fractions. Now, unlike other equations where we do have fractions, we're going to have variables in the denominator in the bottom of the fraction. That's kind of what's going to make these different. Now, these do have restrictions to them, because when we talked about quadratics or higher degree polynomial functions, we said the domain was all real numbers. There's any value of x that we can plug into them. Rational functions do not, because if we look at 1 over x, there is a value we cannot plug in for x for this here. Because what's the one thing we can't divide by? Can't divide by 0. Because if we have 1 over x, x cannot be 0. Because if x is 0, we have 1 over 0. We're dividing by 0, it doesn't work. So there are going to be restrictions. There are going to be what we call vertical asymptotes for these functions here. But before we get into those, we're going to talk about direct and inverse variation. Now, direct variation is given to us by the equation y equals a times x. This is the general form for direct variation. And when we talk about direct variation, we're talking about kind of two amounts, or two things that are either both increasing or both decreasing by a set amount. They're either both going to increase or they're both going to decrease. They're going to go in the same amount or same direction proportionally. They're going to increase proportionally or decrease proportionally. It's going to be one or the other. Because if we talk about, say, area, because if we increase, if it is a square, if we increase the length and width of the square, the area is going to increase proportionally squared. Or if we talk about perimeter, more specifically, if we increase the width and length, that increase will be proportional to the overall perimeter. It's going to either both increase or both decrease. And we could write it as y equals a times x. Now, we can get the a value by itself. A is just a constant term. It's just a number. That's defining the direct variation, the amount that they're going to be increasing or decreasing by. And if we get it by itself, we can say y over x is equal to a, or x over y is equal to a. Either way. But these are two kind of main ways that we can write direct variation. Now with direct variation, when x and y, these two variables are on opposite sides of the equal sign, they're both in the numerator. Neither one of them's in the denominator. They're both on top of the fraction. Even if there's not a fraction written, they're both on top. They're in the numerators. Well, on the same side, they're being divided by each other. Now, we don't have to necessarily have it directly in y over x. It could be x over y, because they are varying the same proportion, just depending on how we look at it. Because if we flipped x over y to y over x, or x over y, either way, it's just flipping a. Because if a was 2 and we flipped x and y, it's now 1/2. Same proportion, it's just different how it looks. Now, the other type of variation that we have is inverse variation. As one increases, the other decreases. So we have y is equal to a over x. And again, just like with direct variation, we can get x and y on the same side and get it equal to a. So for inverse, we can have y is equal to a over x, or we can have it as x times y is equal to a. Both of these are the same. And we can think of inverse variation in real terms, because it could be the same as saying emptying a pool or emptying a tub, emptying a body of water. Because as time increases, the amount of liquid in the tank is decreasing. We have that inverse. One's going up, one's going down. And we talk about inverse variation, we're talking about that opposite. One's increasing, one's decreasing. And that amount that they're increasing or decreasing, that change will be proportional. It will be the same over time. Now, for inverse, if you notice when x and y are on opposite sides of the equal sign, one of them's in the numerator, the other's in the denominator, or vice versa. One's going to be on top of the fraction on one side, and the other is going to be on the bottom. We'll have this flipped. Any questions on any of this here?
Edison Jones, please come to the office. Edison Jones, please come to the office.
Now, the first thing we're going to look at is determining whether each equation is direct variation, inverse variation, or neither. Now, as we just saw, direct variation came in one of two similar forms. Y is equal to a times x, or y over x is equal to a. This is going to be one of these two forms here. Inverse. Y is equal to a over x, or x times y is equal to a. Now, there could be some deviations or different ways depending on what a is, but we can end up getting them into one of these four forms, depending on direct or inverse. And if it doesn't match up to one of these four, it means it has to be neither. Now, if we look at a, x times y equals 5. Would we say this is direct or inverse variation, or neither? Because we look at these four forms, does it match up to one of them? Inverse, we have x times y equals a, yes? And what's the value of a for this problem? 5. So this here is inverse. So the first one's kind of nice because it matches up to one of them specifically. We can see it. So any other questions on A? How about B? Direct, inverse, or neither? So we do have x and y on the opposite side, yes? So for it to be direct, we're looking at y is equal to x times a. Does it match up to that? For inverse, we're looking at y equals a over x. So what is this going to be? Neither. Now there's one main giveaway. In any of these here with direct and inverse variation, are we dealing with addition or subtraction? No. Direct and inverse variation are going to be dealing with multiplication and division only. Either multiply or divide. So if we have addition or subtraction, that should be an obvious giveaway that it is neither. It's not going to be either one. C. What do we think? Direct or inverse variation? So it's a little different. It doesn't specifically match up to any of the four forms that we have, yes? So let's look at x and y. Are x and y on the same side of the equal sign or on opposite sides of the equal sign? Opposite. Is x and y, is one on top of the fraction, one on bottom, or both on top? Both on top. Which one, direct or inverse, has them both on top? Direct. Even though it's not necessarily a fraction, x and y are still both in the numerator, yes? So this here would be direct variation. Now we can still manipulate them to get to be a form that we have, yes? If I wanted to get y by itself, we can multiply each side by 2. Because in all the forms that we have, y is by itself, yes? So if we multiply both sides by 2, these will cancel, giving me y by itself is equal to 2x. Does that match one of our forms of direct variation? Yeah. So if we need to, we can manipulate the equations to get it to look like one of the forms that we have. So here multiplying by 2, which does indeed confirm that it is direct variation. Another way we could have looked at this was 1/2 y is equal to x. Because y divided by 2 is the same as 1/2 times y. So we have a times y equals x. Same form, just looks a little different. Questions on this here? Let's look at the next 3. 6x equals y. Direct, inverse, or neither? Yes. Because it's coming in the form of y equals a times x. We really could say x is equal to a times y. They're the same thing. next one would indeed be and the last one is, and the giveaway is, it's being added. We have the addition of x and y. Questions on these here? I think we feel pretty comfortable with these here, yes? Let's look at the next type after those. Tell whether x and y show direct variation, inverse variation, or neither. Now, with direct and inverse variation, the amount that they vary, directly or inversely, is the same. We have this constant, this constantality. For direct variation, because we had it in the form of y equals a times x, yes? But we could also say that y over x is equal to this constant term a, because they're going to vary that way the same amount every single time. Inverse was our y equals a over x, or we could say that x times y is equal to a, because they should have this uniformity to it, this constant amount that they're changing, either in opposite directions or in the same direction. And if, so for direct variation, we do y divided by x, or x divided by y, and we get the same amount every single time for the given x and y, then it's direct. If we multiply the x and y together and get the same amount for each single one, then it's inverse. And if it doesn't work for either, then it is neither. So for this here, we can start with y over x. It doesn't matter. We could have done x over y. We just need to divide the two and keep it the same setup. So here we'd have negative 12 divided by 2. Negative 12 divided by 2 is indeed negative 6. Now that in and of itself doesn't tell us much, because we need to keep going. So we'll go to the next one. We did the first one. The next one would be negative 6 divided by 4, which is, well, negative 3/2. We can reduce it there. If we kept going, it would turn into a fraction. But are those two the same? No. And again, for this to be direct, all of these have to equal the same amount. Do I need to keep going from here? Yes. Right, they all either need to be negative 6 or negative 3/2. We need the same value all the way down. Now, once we get a different amount for one or the next, where it's not matching up, we can stop, because that a value has to be the same for every term. Because what we're doing is relating each of these terms here. What is the amount that they're varying? Well, the first one says negative 6, the next one says negative 3/2. Those are not the same. So we can move on to the next one, direct or inverse variation, which says that x times y is equal to a, where we should have the same a amount. So we can start off with 2 times negative 12. And 2 times negative 12 is, move on to the next one, 4 times negative 6. Six times negative 4 is negative 24. And lastly, 8 times negative 3 is, so we multiply the x and y values together, we got negative 24 across all of them. So since we do have this constant term, this a value that's the same for all of them, it tells us that this here is inverse, that x and y here vary inversely. Questions on this here? Let's look at the next one. So we have 1, 2, 3, 4, 2, 4, 8, 16. So we can check direct variation, y over x. And we can normally start with the first one. So we would say 2 over 1. And 2 divided by 1 is 2. Then we move to the next set. 4 divided by 2 is 2. So hey, we have a value of a across all of them, yes? Which is 2. Let's go on and try the next one just to see, which is 8 divided by 3, 2.6 repeated. So are all these the same? No, the first two were, but the last one isn't. The last one we tried that it's not. And if we did the next one after it, it wouldn't work either. It would give us 4. So that tells us that it's not direct variation. Now we can try the other one, x times y. Well, 2 times 1 is 2. Our next one would be 2 times 4, which is 8. Those two are not the same. So that tells us it's not inverse. And if it's not direct and it's not inverse, it has to be neither. You can, yes, because it's good to somewhat see, because on the homework and possibly test or review, it might be that it works for the first 3 or first 4, and then the 5th one doesn't work. I think on the review sheet there is one that does work, but you end up approximating it towards the end because of the decimals. Yes, sir. Mm-hmm. But also with inverse and direct, inverse says they're going in opposite directions. Direct, they're going in the same direction. Because if we look at 1, or A, 2, 4, 6, 8, these are increasing, they're getting bigger, yes? Now with Y, I wouldn't necessarily think of this in terms of negative, because a smaller negative is technically bigger. But think of it as the number itself. We're going from 12 to 6 to 4 to 3. Those are decreasing. We're getting closer to the origin. So the x values are going away from the origin, the y values are going towards it. They're going in opposite directions. One's going up, one's going down. So most likely this is going to be inverse. If we look at B, 1, 2, 3, 4, the x values are increasing. The y values 1, 2, 4, 2, 4, 8, 16, they are increasing. So most likely, if it's going to be one or the other, it's most likely going to be direct because they're both going up. But they're not going up by the same amount from one to the next, so it's not direct. Questions on this here? Let's look at least one more. So let's look at these two here. So if we look at number 4, the x values are what? -4, -3, -2, -1. So are they increasing or decreasing? They're going closer to the origin or away from the origin? Decreasing, they're going closer to the origin. The y values 20, 15, 10, 5. They're decreasing, they're both going down, yes? They're both going towards the origin. So most likely, which one of these two is it going to be? Direct or inverse? Direct, because they're going the same direction. So we can see, so looking at y over x. So we can say 20 divided by -4. Or 20 divided by 4 is 5, and it would be negative. All right, guys. 15 divided by -3, -5. 10 divided by -2 is -5. And lastly, 5 divided by -1 is, so we get the same value across all of them. Yes, so this is almost direct. Because our direct is our y over x is equal to a, and inverse is our x times y is equal to a. It's a little flipped on how it seems. Any questions on this so far? We ready to look at one last one before we move on to the last thing we're going to cover today? As we look at this last one here, the x values 1, 2, 3, 4, they're going away from the origin, 0, 0, on the graph. And if we look at the y values, 60, 30, 20, 15, they are approaching it. So there's a good chance this is going to be what? Inverse, if it's going to be one of the two. So we don't necessarily have to do the division first. If it looks like it's probably going to be inverse, we can start with it first. So if we multiply them, so we have 1 times 60, 60, 2 times 30, 3 times 20 is 60, and lastly 4 times 15. So we get the same amount across all of them, yes? So this is inverse. Do we even need to check for direct variation? No. There are some that do vary inversely and directly, but those are a specific case. Here we're just looking for one or the other, not both. So this one here would be inverse. Any questions on any of this here? Let's look at the last thing that we're looking at here. Now this one here, we're going to find an equation and an amount. So there's two parts to each one of these here. Now they tell us x and y vary inversely. So if they vary inversely, our main equation we're looking at is either this here, y equals a over x, or x times y equals a. Very inversely, and y is 4 when x is 3. Write an equation that relates x and y. So we kind of have it here. We just need to find the value of a, and we're done with that part. Then find y when x is negative 2. So to find the equation that relates x and y is really this here, y equals a over x. We just need to find the value of a. Because if we find the value of a and plug it back in, we'll have the equation. Then we can use that equation to solve the second part. Now to find the value of a, they gave us the one piece of information that we need. They said when y is 4, x is 3. And we can plug it in. So we're saying when y is 4, so 4 is equal to a over 3. When y is 4, x is 3. So we're finding the value of a first. Any questions on how we set this up? Now to get a by itself, we need to get rid of the 3 or simplify the 3. So the way that we can do that is multiplying both sides by 3. I'm going to step this out step by step on this first one here. We normally are used to seeing that, well, a over 3 times 3 is just a. The 3's cancel. Now the reason that this works is when we multiply a fraction by a whole number, we multiply with the numerator. So we're really saying over here that we have 3a divided by 3. On the left-hand side, 4 times 3 is 12. Now what is 3a divided by 3? Anything divided by itself is 1. So we just have a is equal to 12. Because 3a divided by 3 is a, and we have 12 on the other side. So our equation that relates x and y inversely is y is equal to 12 over x. So that's the first half. Questions on how we found the equation? Now we need to find y when x is negative 2. Plug it into that equation. Replace x with negative 2. Then simplify. 12 divided by negative 2 is, there's our two answers. The equation that we needed is y is equal to 12 over x. And the value of y when x is negative 2 tells us that y is equal to negative 6. Questions on this here? Let's look at another one. The variables x and y vary inversely, and y is equal to a when x is equal to 4. Write an equation that relates x and y, then find y when x is 16. So our first part is finding the value of a so we can set this equation up. Y is equal to a over x. Now they told us y is 8 when x is 4. So what we can say is 8 is equal to a over 4. Y is equal to a divided by x. We plug in x and y. Now we can do the exact same thing we did on the last one. So here we can multiply both sides by 4. And as we saw with the last one here, the 4 and 4 will simplify to 1. They'll simplify each other out, which will give us a by itself. Now we just need to multiply the other side. 8 times 4 is, so we can plug it in for a. So y is equal to 32 divided by x. Questions on the first half of this problem? Now the last half is to find the value of y when x is negative 16. So we have 32 divided by is negative 2. 32 divided by negative 16 is negative 2. Any questions on any of this here? Do we need another example of one of these here? Do we feel comfortable with this? So we need to find the equation and the value of y from the given x that they give us. And that's it. Yeah, we can define it based off these amounts, because if we know the amount that is increasing based off time, how much is coming out of the tank, we can estimate the approximate time that it would take to empty it. Let's look at this last one here. This one's it's not really any different, but we do have a fraction. It doesn't change the process because we know y and x vary inversely, and we want to find the equation first. So y is equal to a over x, so we want to find the value of a first. And then we want to find the value of y from the given x value. Now they tell us y is 16 when x is 1/2. So we need to find a. So what can we do first for this here? Well, we can multiply both sides by what? 1/2. Because here the 1/2 and 1/2 will cancel out. Now we need to take 1/2 times 16. 8. Half of 16 is 8. So y equals 8 over x is the equation. And what value of x do they want us to find the y value for? 2. Because they gave it to us up here. Then find y when x is 2. So 8 divided by 2 is. And that's it. So just because we have fractions doesn't mean the process changes or anything's different. It just looks different. Any other questions on any of this here? And that's it.